On a clear dark night, far away from city lights, the Milky Way can be seen stretching across the sky from horizon to horizon. This fuzzy band is actually the light from hundreds of billions of distant stars that make up the pinwheel-like disk of the Milky Way Galaxy. How does something shaped like a disk appear as a band in the night sky? From Earth, we see the Milky Way not from above, but from inside the disk itself. Rotating this view above the plane of the stars we normally see edge on, the familiar image of the spiral disk emerges. The Milky Way is about 100,000 light years across. This means that light arriving today that traveled from one edge to the other started its journey around the time the first modern humans began migrating out of Africa. There are about 200 billion stars in the Milky Way. All of the familiar stars and constellations, and nearly every star you can see with the naked eye, is located within less than a few thousand light years of Earth. The stars that form the 12 constellations of the zodiac fall, by definition, onto the plane of the ecliptic. The ecliptic plane is a disk centered on the Sun, which contains the orbits of the planets. Seen from Earth, the Sun, the Moon, and planets all appear to follow an arc-like line across the sky, passing from one constellation of the zodiac to the next. The ecliptic plane intersects the galactic plane at around a 60-degree angle, causing the stars of the zodiac to appear as if they were the spokes of a slanted wagon wheel. The stars that make up the constellations appear to be next to one another as seen from Earth, but in reality, they are spread across varying distances. It's only when seen from our solar system that the angles to each star line up in just such a way to produce the familiar shapes we recognize as the constellations in the night sky. Astrophysicists have spent decades studying and modeling the physics of how stars form, how they evolve, and also how they end. The beginning of a star's life is intimately connected with its fate. The initial size of a star dictates nearly everything about its life cycle, including ultimately how it will die. For small to medium-sized stars, up to around 8 times the mass of the Sun, running out of hydrogen fuel to power fusion means that the star's core will condense into a sphere of mostly carbon and oxygen. As the last of the fuel runs out, the outer layers of the star expand and cool into a red giant. These outer layers leave behind a planetary nebula, while the remains of the core contract into a white dwarf. A white dwarf is still hot enough to glow like a star, but there is no longer a fusion reaction in its core. This is the ultimate fate of our own Sun. For more massive stars, running out of fuel for nuclear fusion has more dire consequences. The force of gravity during implosion of these stars is so great, even subatomic forces cannot resist. The immense rebounding explosion is one of the most violent events in the universe, a supernova. The remains left behind by dying stars form many of the spectacular deep sky objects we've become accustomed to seeing in images taken by the Hubble and James Webb Space Telescopes. Dozens of catalogs have been created to collect and track deep sky objects. One of the earliest and most famous of these catalogs was compiled in the late 18th century by a Frenchman named Charles Messier. Ironically, Messier wasn't interested in the objects themselves. He was chasing comets and wanted a catalog of fuzzy objects he could ignore. Messier's final catalog contains 110 objects, many of which are actually galaxies themselves. The objects in Messier's catalog that are nearby in the Milky Way include nebulae, open star clusters, and globular star clusters. Deep sky objects in Messier's list are often still called by their list numbers today. The first object on the list is the Crab Nebula, or M1. The Crab Nebula is a remnant of a supernova about 6,000 light years from Earth. Historical records indicate that the supernova that created the Crab Nebula was observed from Earth in 1054. The brightness of the nebula is enhanced by the immense energy pumped into the surrounding gas by a pulsar left behind by the dying star. Some of the most spectacular nebulae in Messier's catalog include the Eagle Nebula, home to the famous Pillars of Creation, the Orion Nebula, the Trifid Nebula, and the Ring Nebula. The closest Messier object to Earth is M45, which is only around 400 light-years from Earth, about 10 times farther away than the closest star, Proxima Centauri. M45 is a familiar open cluster of stars, also called the Pleiades, or Seven Sisters. This group of stars is sometimes mistaken for the Little Dipper because of its ladle-like shape. But while the stars of the Little Dipper, also known as Ursa Minor, vary greatly in age and are spread across comparatively large distances, the stars of the Pleiades were all born from the same stellar nursery around 100 million years ago. These stars are comparatively young. Dinosaurs already roamed the Earth when the Pleiades were still just a swirl of gas and dust. The most common type of deep sky object in Messier's catalog is the globular cluster. While these clusters of stars are not nearly as visually stunning as planetary nebulae, they can contain tens of thousands or even millions of individual stars. Some of the stellar inhabitants of globular clusters are the oldest stars in the universe, providing scientists with invaluable data to help understand stellar physics and galaxy formation. In addition to stars and their remnants, the Milky Way is home to an estimated 100 billion planets. Of these, as many as 10 billion exoplanets may be orbiting stars like our own Sun in the so-called habitable zone. The first exoplanet to be discovered was 51 Pegasi b. This gas giant planet is comparable in size to Jupiter, orbiting a star that's slightly larger than our Sun. The 51 Pegasi system bears little resemblance to our own solar system. Despite being a gas giant larger than Jupiter, the planet discovered in 1995 orbits its star at a mere 5 million miles, around 1/10 the distance from the Sun to Mercury. And while it takes Mercury around a quarter of a year to circle the Sun, 51 Pegasi b orbits its star in just 4 days. Since the launch of the Kepler Space Telescope in 2009, the discovery of new planets has exploded. To date, more than 5,000 planets have been confirmed, with over half of those having been discovered using images from the Kepler Space Telescope. The number of planets it has revealed in just this single direction attests to the enormous number of planets that await discovery in the Milky Way. In 2013, Kepler's stabilization system failed, and its mission was presumed to be at an end. Then engineers devised a way to use pressure from the Sun to stabilize the telescope, resulting in 4 additional years of operation. During the K2 mission, the Kepler Space Telescope was literally floating on the solar wind, now pointing along the ecliptic plane instead of perpendicular to it. Over 500 additional planets have been confirmed from the K2 mission, with close to 1,000 candidates still remaining. The Optical Gravitational Lensing Experiment, or OGLE, has found dozens of planets using a unique approach called microlensing. Light from a distant star is momentarily bent and focused around an intervening star or planet, causing a sudden burst of light. Astronomers can then analyze the resulting light curve to extract the telltale signs of orbiting exoplanets. The true successor of Kepler is the Transiting Exoplanet Survey Satellite, or TESS. Launched in 2018, TESS is systematically surveying the entire sky. TESS has discovered over 400 planets and registered over 7,000 additional candidates, waiting for confirmation. Many other telescopes and observatories have joined in the hunt for exoplanets. In addition, all the data from telescopes like Kepler and TESS have been made available online to the general public, along with tools to help amateur astronomers analyze light curves. The search for exoplanets has only just begun. At the center of the Milky Way is an enormous collection of stars called the Galactic Bulge. There are so many stars in the Galactic Bulge, there is no darkness in any direction, save one. At the very center of the Galactic Bulge is a supermassive black hole, 4 million times more massive than the Sun, and over 15 times its diameter. No light comes from that direction, because any light that goes into the black hole never comes out again. In 2022, astronomers managed to take a picture of the hot gas and dust swirling around the black hole named Sagittarius A, providing overwhelming evidence that the core of the galaxy is indeed the home of one of the most bizarre and mysterious objects in the universe. Surrounding Sagittarius A is a multitude of ancient stars. To put this into context, the closest star to the Earth is 4.2 light-years away, a little more than 1 parsec. That means that within the radius of 1 parsec around the Sun, there is exactly 1 star, the Sun itself. Within the same radius around the center of the Milky Way, there are around 10 million stars. Gigantic black holes aren't the only bizarre effects we see at the galactic scale. The Milky Way takes about 250 million years to rotate once around. The problem is that the outer stars in the disk are moving faster than they should, according to the amount of gravity we expect from the mass visible in the galactic disk. The most popular explanation for this effect is that there is more mass in the disk than we can see using light. In fact, decades of research show that if this explanation is to be believed, the missing mass isn't just hard to see, it doesn't seem to interact with light at all. This hypothetical invisible mass has been named dark matter. The enigma of dark matter isn't limited to the Milky Way. The problem of missing mass gets worse the farther out we look. Even the motions of galaxy clusters and the structure of enormous galaxy filaments appear to be dominated by this mysterious phenomenon. Whether these effects can be explained by the existence of exotic dark matter, or whether a fundamental change to our understanding of gravitation itself will be required, the problem of dark matter isn't going away. Current estimates suggest that over 1/4 of all the mass energy in the universe is made up of dark matter. The Milky Way Galaxy is home to a seemingly limitless number of fascinating objects and behaviors, many of which we are just beginning to discover. It may turn out that ours aren't the only eyes looking, and that we are also just one of the fascinating discoveries waiting to be uncovered by residents of another part of the Milky Way Galaxy.